Okay, so I've changed things a little bit. It's not the exact same thing as our applied problem, but it's similar enough so that hopefully you'll know what we got to do based on this. Three things in the budget: public welfare, non-college education, and hospitals. And so we're trying to decide that the town board of directors is trying to decide which ones to reduce, or maybe they're going to reduce all of them, maybe they're just going to reduce some of them. So they have some options, and to list out all the options based on this criteria, we should use a truth table because it's really hard to juggle those two facts interacting with one another. So we'll do what the suggestion says. In part one, it asks us to make a truth table with P being public welfare reduced. That's true. P would be true in that case. If P is false, that means that public welfare was not one of the ones to be reduced. Okay. So let's make that truth table. P is public welfare, Q is non-college education, and R is hospitals being reduced. So just like we did in Newton, we're going to go true, 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 false, 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 false. Those are all the possibilities. Well, when we list out the 8 different combinations using these true or false patterns, we'll have all the different possibilities without those conditions applied at the beginning. So nothing new here. Nothing exciting, I should say. True, false. So what was R? R is hospitals reduced, so true means hospitals was reduced in row 3. False means hospitals were not reduced. We're not one of the ones chosen to be reduced. Hospital reduced, hospital not reduced. Okay, so those are the 8 possibilities for true and false combinations. So let's fill this part out. If non-college budget is not reduced, so Q was the non-college budget, non-college education budget, and it's not reduced, so that's the negation of Q is what they just said right here. Not reduced. We said true means it's reduced, so false would mean it's not reduced. So okay, sorry about that. So if that's not reduced, then the public welfare budget will be reduced. So public welfare was P. So if Q is if the negation of Q implies P is what that first one translates to be. So I need to have a negation of Q column. So everything in Q gets changed from true to false, and vice versa. Maybe typing this would be better. I should have done that because then it's all in a computer generated row. But and now I can fill out this just like we did in Newton. Not Q implies P. So the way we fill that out is that if the first part of the statement is true, then the second part has to be true in order for us to mark it be true. So the first part of the statement is false. So in a conditional statement, if the beginning of the condition is false, then you mark this true. So it doesn't even matter what P is. If not Q is false, then we mark it true. So in the second row, not Q is false, we mark it true. Okay, third row, not Q is true. So in order to mark this true, P would also have to be true. So true implies true, that's true. And this one, true implies true, that one's also true. So this one's false, it means we don't even look at P, we mark that true. This one's false, we mark it true. So true implies false, that's false. So if you start with a true in a conditional, then the end has to be true, or else you mark the whole statement false. Okay, so we start with true. True goes here. False goes over here. So this is a false conditional. True implies false, that's false. Okay, so we filled out this first one. Non-college budget is not reduced, and the public welfare budget will be reduced. And then this one says the hospital budget can be reduced if and only if. So hospital budget reduced, let's stop right there and put the symbol, that's R. And then the words if and only if means that both of them have to be the same with one another. So the hospital budget can be reduced if and only if non-college education is reduced. So that's Q. So we need to fill out that part of the truth table. Okay, so I'm going right through the rows, and with biconditional, they both have to be true or they both have to be false. Otherwise, you mark this statement false. So we've got R is true, Q is true, we mark this row true. R is false, Q is true, those don't match, so we mark it false. R is true, Q is false, so we mark it false. R is false, false, that means we mark it true. This is different than AND, right? R and Q, that one we would have marked false because with the AND operation, they both need to be true. With the if and only if statement, they both just have to be the same. So that's why I marked this one true, because they're both the same. So true, true, those are the same. True, false, those are different. True, false, those are different. False, false, those are the same. And so for both of these statements to be true, to satisfy both of the board's conditions, we need an AND statement. So we need the first thing we wrote down, put that in parentheses, that needs to be true, and the other one needs to be true. If we fill out the truth table and we find out they're all false, then we want to say, hey, there's no way we can satisfy your criteria here. Okay, so true, true. We mark this one to be true. True, false. They're not both true, so we mark this false. True, false. So they're not the same. True, true. They're both the same. True, true. They're both the same. True, false. They're not the same. They're not both true. Okay, and I think I might have been saying something wrong there. For this to be true, they both need to be true, right? That's why we mark this one false. This is different than biconditional. This is what I was just saying earlier. All right, so to satisfy the board conditions, what we found out with our truth table is that there's only three possibilities. There's this first row right here. There's this row right here. And there's this row right here. That's the only place where those two statements are true. Okay, so that can help us with part two. Part two says the public welfare is reduced. So public welfare was P, I think. Yeah. So if P is true, and if non-college education is true, non-college education is Q, so Q equals true. So if this is true, will hospital. So what we need to do is find out in our table where P is true and where Q is true. P is true, Q is true is right here. And it's also true down here, but we're ignoring this second row because this would violate one or both of those board conditions. Okay. So the only one we consider out of these two, this is P is true, Q is true, this is P is true, Q is true, is the top one because that's the only one that satisfies the board's conditions. So what do we say about hospitals? R, we say that hospitals, yes, it will be reduced because R is true in that row. So for part two, it'd say hospitals reduced by our truth table. Then for part three, you can pause if you haven't read through this because this is my made-up example. It's similar. Public welfare is not reduced, so public welfare was P, so that means P is false. It's not reduced. And non-college education is not reduced. So non-college education was Q. And to be not reduced, that's false. We said at the beginning, true is going to represent reduced. So false. Non-college education is not reduced. So there's two places in the table where P is false and where Q is false. These two rows right here, right? And we didn't have those rows highlighted because one or both of the board's conditions are not met for these two rows. So this is a situation where I'd say it's impossible to determine the board's conditions are violated when public welfare is not reduced and when non-college education is not reduced. Okay, so that's one where it'd be impossible to determine. So don't assume that either part two, part three is not possible. Okay, they both might have exact answers like this one, like when we found R is true, that hospitals are reduced. Okay, so I know that's tricky because I know a lot of us struggle with truth tables. So chin up because truth tables are almost done. We'll have a test on them and then you won't have to see them again for this class. But hopefully this problem just gives you an idea of how truth tables can help. I don't know enough about computer science and what they're doing these days, but one of the professors I had in grad school was working on symbolic logic, translating human phrases into symbolic logic, and I've got to think at some point that those big artificial intelligence programs like ChatGPT were using that at some level to try to give us the answers that we get to our questions, right? Because if you can break things down into true or false statements, then a computer could easily make all these computations and make a truth table. That's nothing for a computer. It's harder for us because we have to do a lot of writing. Okay, so that's how truth tables could actually be applied. Kind of a made-up setting, but you could easily see how we could put this in a better, more helpful context. Please let me know if you need help. I can't give the answers directly, but I'd be happy to point you in the right direction if you've watched this video and you're still stuck. Okay.